Welcome to Android Study Jam Session 5. I'm TR Sai Rakshit, the technical team member, and I'm also the facilitator for the Android Study Jams. And today we'll be taking a look at session 5, and we'll be also seeing some topics like SQL and Room that we are going to cover in this session. So I welcome you all once again to Android Study Jam session 5, and let's get started with session 5. So this is one of the common slides that I put in before every session. So before every session, I make sure that I'm including the equipment that is required for each student. So I hope all the equipments are ready with you, and all throughout this 5 sessions, you have been following through all the 5 sessions. So some of the basic equipment that is needed for each student include a computer, internet connection, Android device and USB cable, and of course Android Studio. So these four are the basic equipment that you need in order to run Android Studio projects. Moving on. So like we discussed in the previous slide, Android Studio, if you're coding applications, if you're basically building mobile applications, you'll definitely need Android Studio for that purpose. Android Studio is like that integrated development environment where it would help you to basically run the code and also test the code. So you could also have a physical device in order to test what would be the output for your program, or you can also use a virtual emulator that already comes with Android Studio beforehand. So these two are the ways in which you can basically run your Android applications. One is through the virtual emulator that is already present, and the next one is via a physical device by connecting it to the USB. So once you connect it to the USB, you just have to make a few changes in the configurations in the settings. And once those configurations are being made, it is really simple to start building your app. So Android Studio is that requirement that you'll need to do. So that is about the virtual emulator and also the physical device that you'll be using. And talking more about virtual emulators, a little bit more deeper into virtual emulators. So like we discussed, you can emulate an Android device on a computer and you can run the app on the emulator as well. So this is what we have been discussing till now. Let us assume for some reason that you actually don't have a physical device with you. What you can do is you can basically install an emulator that already comes with the Android Studio application. So once you install the emulator that already comes with the Android Studio application, it is really simple for us to run apps using that. All throughout this series of all these 5 sessions, we have basically been using only the Android virtual device that is already present. So moving on, so these are some of the prerequisites that you would need so as to study Android study jams. So you basically need to have basic computer literacy, you need to have basic math skills, computer and headphones, internet connection, and Android device and USB cable. So the last one is optional. So if you already have a virtual emulator already installed in your Android Studio, you would not basically need this Android device and a USB cable. But computer literacy is very important and basic math skills are very important. And even in session 4, we saw many instances where you had to invoke some concepts from the past. You had to invoke a few Java concepts that you basically learned. You need to know what a class is. You need to know what are methods, how to call methods, what objects are, how can you use an object and call a method, and so on. So these were some of the basics that we discussed in all these 4 sessions that we conducted so as to be more familiarized with the language and get a more grip or hold on the language. And the other 2 points we have discussed in the previous slide as well. So computer and headphones and internet connection obviously you would need. Moving on. So these are some of the learning objectives. So all throughout these 5 sessions, we have basically built many apps hands-on. So we have built many apps hands-on, and we successfully installed Android Studio on our computer, and we parallelly also discussed many programs. We saw what exactly recycler view is. We saw what exactly the different kinds of views are, how to position them on the screen. We also saw the distance that you need to maintain so as to make the Android application look good. We discussed about user interfaces. We also discussed a little bit about user experience, etc. And we also studied how to bring in buttons. We saw different kinds of views, and all throughout these 5 sessions, we took the case study, like we saw how InShot's application is basically displaying the news, where the data is being displayed, how is it being displayed on the Android application screen. We also took the example of the Times of India application, and we saw how they are able to incorporate pictures, how they are able to incorporate headlines, and also the news article that basically comes after the headline. So we saw how, with what mechanisms are they storing it, etc. So how they are also fetching that using this recycler view. We basically defined recycler views, and we saw how that recycler view is basically getting recycled after the display of one news app. We saw how that is being recycled and coming back again for displaying the rest of the news apps. So news. So all these things we had learned in the previous session, and you'd also learn the basics of Kotlin programming language. I think now most of us would be quite familiar with Kotlin programming language because we have studied a lot in it. Moving on. So these are some of the basics that we had learned. So we had learned an introduction to Kotlin. So we basically saw what Kotlin is. Then we also created our first app using Kotlin. And then we saw what were layouts. We understood how to add a button to an app. We also understood how to get user input. So basically in the previous sessions, what we did was we understood how to take the user input and how to perform a very simple calculation using a calculator. We understood how to perform addition operation using by making a simple calculator and displaying a scrollable list. We saw what scrollable list was. So basically how to display the list of text and images in an app. So we compared this to InShot's application, if you could recall, and we saw how the news articles are being basically displayed. Then in the most recent sessions, we saw navigation between screens, and we also saw navigation component, how to use Jetpack navigation component to make it easier. We also did a few hands-on applications using these navigation components. And then in the more recent sessions, we saw what are the different architecture components that were involved. We also saw coroutines, what coroutines are and how they are actually helping us build more complex applications. And in the last session, in the previous session, we saw how to get and display data from the internet. We saw HTTP protocol. We also saw what exactly REST is, representational state transfer. So we saw that one, and we also saw the different protocols that are governing it. And if at all you want to display some text or image or some content from the internet, we also saw how do you import that particular how to basically bring that content or stuff that is present in the internet and how to display that particular article on the Android application. So we saw that as well. We understood what this HTTP does, and we saw what were APIs as well. So we saw what were application programming interfaces. So all these things have been covered in the previous sessions. And in today's session, what we're going to do is we are going to basically look at SQL. So SQL is structured query language. So we are going to see how data is being stored. Definitely for performing any operations in our daily life, you need to store some data. There should be a database and we have to store some data. So for that, what we would be doing is we would be today understanding about SQL, what exactly SQL is, and when we also have a database, how to query some results from the database so as to get the appropriate results. So you can basically even compare this with modern applications and try to relate it. When you have a bigger application with you in hand, you'd be needing SQL. You need a database to store vast amounts of information. So, for example, let us take this IRCTC booking website. So, for there are so many train tickets that are being booked on a daily basis. So, in order to store all these passenger records, in order to store all the ticket information and ticket related details, you need basically a huge database to store it. Or let us assume that you are building a application, a news application, you need basically a place where you can store all these news articles. So for streamlining all these processes, basically we have something called SQL, that is structured query language. And SQL is nothing but a way to query. Using SQL, you can basically query the data, and we would be using relational databases here. So we'll be looking at what relational databases are, and we'll also be hands-on looking at how these queries are written and how to retrieve those queries from a database. So we'll be looking at various SQL commands in this session. And we'll also see what exactly is room. So we'll discuss about what room is. And finally, we would wrap up the session with understanding how to schedule tasks with work manager. So basically, we'll be looking at what a work manager is, how to use a work manager, and we'll introduce you to the work manager concepts, where we'll be understanding how to perform some basic operations, and we'll also be studying what's the importance of work manager. So that's about today's session, and we'll be finished with the entire syllabus of the Kotlin and the track that we were supposed to learn all these 5 sessions. Let's get started with the first concept of this session. So the first concept of this session is basically we'll be understanding what exactly SQL is, right? So in computing, a database is simply a structured collection of data that can be electronically accessed and written to. So there are a few keywords here in the first point as well. So it's basically a structured collection of data. For any application that you build, you need to be having a database that is, related with it, attached with it, so that for that particular application, you need a lot of data. You need to do some data processing work, a data processing job in order to get some kind of benefit out of that database. So for better profitability, you need a database to store all the data that you have. And basically, the world is filled with data. So you would need to understand the data that you have and try to make logical sense of the data that you have in your database. So that is the reason we are using SQL here. Databases can store any of the same information you can represent in an app using Kotlin. So basically, all the information that you can basically, show using programming in Kotlin, basically all the data can be stored in a database. So it is much better if you have all the data that you need to run an application in a database, so that easily you can fetch the data you want at the right time. So the third point is on mobile devices, databases are commonly used to save data from a running app so that it can be accessed next time when the app is opened. So what this point says is, again, if you take the InShots application as an example, what you would see is you would basically see how the news articles are being fetched, and once you leave the news application, the state is being saved, and once again when you open the news application, you basically start from the same news that you left. So that is about this point, without retrieving the data from another source like the internet. So basically on your mobile device only you wanted to store all that information, or you wanted to store that data. And every time you open the news application, you don't want to keep retrieving the data from another source. So it would be much beneficial and it would be much faster if you have the data basically on your mobile device itself. And since you're storing the data on your mobile local device itself, this process is basically known as data persistence, because the data that you have is being basically persisted on your Android device. So this concept is called data persistence. I'll just recap this slide. And in this slide, basically, we were talking about SQL. So SQL basically stands for Structured Query Language, which means if you have data in a database, you're using the structured query language in order to retrieve the data from the database. And what kind of data we have in our database? Some data that is critical to running our application. So that kind of data is basically stored in the database. And you would use SQL in order to retrieve that important information that you basically store in your database. And the other point here to remember is the database that we have, whatever data that we are storing in our database should be in a very structured format. So a structured collection of data. So it is not just random data that you're putting into your database. It is a structured collection of data that you're putting into your database. So that is something we need to take care about while we were talking about SQL. So that is an important point. And we also saw what data persistence means. So data persistence means we understood that every time you open the application, you need not fetch all the data from the internet always. So uh, probably if you're in a place where there is less internet connectivity, you might not be able to retrieve all the data in a very short interval of time. So a better way to deal with this situation is, what if you have the data on your mobile device itself, and when you open the application, if the data is immediately accessible, it becomes much faster. And where can this data be stored? This data can be stored in a database. So that is about the content of this slide, slide number 13. So this is where I'm giving a more formal definition to SQL, and we'll basically see what exactly a relational database means. So when we are talking about data persistence, we offer here the term relational database. So what exactly a relational database is, we'll see right now, and how to perform operations on the relational databases. We'll look at that by taking an example in the Android Studio application itself. So a relational database is a common type of database that organizes data into tables, columns, and rows. So relational databases and SQL is a very important topic when you consider it from an interview point of view as well, because they will ask queries, and it would be really beneficial to you if you know how to basically code using uh, how to basically retrieve data from a database. So if you're precisely able to retrieve the exact data that is required for building an application, it would be really beneficial for you as well. Not only while performing or making some Kotlin application. And the third point says a table in a relational database works the same way. Besides representing data comma tables can also reference other tables so that you have some kind of relationships between them. So this is a slightly a complex topic when you take into consideration database management systems. And here it need not be only in one table. So all the data that you want to retrieve need not be only in one table. So what we can do is we can reference it to another table and also have some kind of relationship between these tables so as to retrieve the data more efficiently by referencing many tables at the same project that are present in the same project. So that is what the third point basically talks about. It says that you can reference other tables also so that you have a relationship between them. A classic example would be the table students, teachers, and course. So there are a lot of relationships that you can basically build from students, teachers, and course. So a teacher will teach a course and a student will study a course, and the student would and the teacher would also teach the students. So you can make many relationships among them. I just very quickly summarize the slide. So we were talking about data persistence in the previous slide, which means that you are going to basically persist that data in your Android device. So when you basically persist some data in your device, what happens is it is basically present in your device and you need not open you need not fetch the information from the internet every time you open that particular Android app. So that is what is meant by data persistence. And we also learned about what relational database is. So relational database is a common kind of database that where you can organize your data into tables, columns, and rows. And we also studied that all the data that you have in a particular application need not be only stored in one table. It can be stored in many tables, and you can also start referencing them so that you can build some kind of relationships among them. So once you build some kind of relationships among them, you can start basically referencing the common attributes between these tables so as to retrieve data in a much simpler way. So that is about the relationships among the tables. And a classic example would be students, teachers, and course. So while we were talking about students, teachers, and course, we'll also see a diagram that represents the entire scenario. So this is the diagram that basically explains the many relationships between students, teachers, and courses. Right. So we can take our Amrita itself as an example, and we can see many such relationships over here. For example, let us go through each and every relationship one by one. So we can see in the diagram that a student take many courses. So this is of course a fact. So if we look at our timetable, we have so many courses that we are enrolled to at the beginning of each semester, and we would do that as well. So that's what the first arrow means. So a student takes many courses, and from the other side, if you see, a course also has many students that are enrolled. So if we take one particular course from the entire timetable, uh, we can see that that course would be having many students that are enrolled in it. So it will be basically having the entire class only enrolled in it. So that is about that arrow or that relationship. And from a course perspective, when we see each course has one teacher and a teacher teaches many courses. So this is also again applicable as well. So when we take the example of one teacher, so we can see that teacher basically teaching courses for your semester as well, and probably the same teacher would take the course for the future semesters or lower semesters than you as well. So that is another relationship. And we can also see teachers teaches many students. So that is again another relationship. So if the teacher is present in the class, um, he basically does not only teach to you, he teaches to many students. Many students are present in the class. And the last one says student has many teachers. So from a student's perspective, again, if you see, and if you go to the staff room, the student has many teachers that the student can interact with in order to clear a doubt. So these are a few relationships in a table. So this is how it's being represented. We saw that data need not only be present in one table, it can be present in many tables, and you can have basically some relationships between these tables in order to uh, streamline the process of retrieving data from the database. So what we would do now is we would basically be looking at a hands-on activity. So in this hands-on activity, what we would do is we would basically take an example application and we basically run the different kinds of queries that are possible, and we'll try to query out the very important queries that are associated when we are basically handling databases. So if at all you want to retrieve data from the databases, you'll be using a lot of queries. And we also saw that it's basically we are following a structured way in order to retrieve data from a database. So if I shift my screen towards the SQL basics, so here what we have is here we have the entire application. So on the left hand pane, you can see the entire application. And the application here that we are basically looking at is a park application. So this is a park application or a park database, which means that we can see a lot of features that are relating to a park. So California park.kt is the uh, file here, and if we see the import statements, here what we are doing is we are importing a lot of statements. We are importing the statements from the room, basically, like we discussed what in the starting of the presentation, we saw what exactly room is. We'll be studying more about room in the future slides as well. And here, what you're doing is basically you're importing column info, entity, and primary key. We saw what was the importance of importing a lot of libraries. So you can compare this to library elements. So when you go to a library, you go to a particular subject, and once you enter that subject section, you can basically take one book from that. So um, I hope you are able to recall the concepts that we studied in the previous session. So when we take this app, we have a database. So this is the app inspection window. So if at all you want to go to the app inspection window, what you have to do is you have to basically go to view and you have to go to tool windows. And once you go to tool windows, you have to basically click on this option called app inspection. So when you click on this app inspection option, this app inspection box appears where basically you can see the databases that you have for your application. So this entire all these files basically consist of the application or the important files that we need to have to basically make our application run. And when we see the app inspection box here, so we have the databases. So we have this app database and we have two databases inside that database. And for now, we are concerned with the Spark database. So if you go to the Spark database, you can basically see the entire database itself here. So like we discussed, a database is nothing but a place where you want to store your information. So this is what a database is all about. And you can see there is ID here, there is name, there is city, there is area in acres, park visitors. Basically, area in acres is the area that a particular park has, and that is given in acres. And then you have park visitors. You have it. You have an established column. You have a type column, whether it is a monument or whether it is a national park or whether it's simply a recreational area, etc. So what happens when we run this app? So basically here you can see that for my Pixel 3a Excel API 27. So Pixel 3a Excel API 27 is nothing but my virtual emulator here, and it's detached over here. So let's just attach it right away. And to attach it, you just need to run the program. So Once the build process is done, what happens is it basically builds the entire application. And we can see this was basically the previous app, and now the cache of the previous app is being cleared. And once the cache of the previous app is being cleared, the new app basically loads. And once the new app loads, the Pixel 3a Excel API 27 is now attached to this particular application. And once it is attached, now you can start basically querying whatever data that you want from your Park application. So you have your Park application here, and you can start now querying results in order to display the relevant information that you want in your application. So this is what it is all about. And today, what we would do is we would basically write a few example queries and try to take out some important data that we think it might be useful for our. So if you go to the first tab, basically what the first tab says is I have a command called select star from park, and select star from park is nothing but a command that you issue if you want to basically select all the data that is present in your application. So in your database, as we saw, we have a whole lot of information that we have, and if you want to basically display all of that information, you write select star from park. So that is the command you would be giving. You can see that the statement was run successfully, which means that there was no problem as such in the displaying of the result of whatever SQL query that we have run. And select star from park is nothing but is going to basically give you all the data. So it is going to give you the entire table in front of you. So this is the view of the entire table if you wanted to see. The live updates would be happening here. You can even toggle that button to check it. But in this tutorial, we aren't going to do. And the second query says you have to select the city from the park. So what this actually means is you have to select the column called city from the table called park. So if you see the park database here entirely, you have this city column. So basically, this is what is the query here. So you have to select city from the entire table called park. And if I run this, rightfully you'll get all the cities. So that's what we had also basically discussed about when we shifted to the park database. So he wants all the column cities. So he wants all the cities, probably the names of all the cities that are present in that particular. Now this statement is slightly complicated, and now it says select name established comma city from park. So what would happen here is all the three columns would be basically selected from the park table. So again, if you look at the park table, you have this name, city, park visitors, established, etc. So you're basically now not getting the results of one column, but you're basically getting the results from so many other columns as well. So that is what this command does. So if you hit the run button, the statement would be executed and you'd be basically getting the query that you wanted to run. So this is about the third query that we ran. So until here, does anybody have any doubts about how to select a particular column from a particular table? So in my next query, what I'm saying is I'm selecting name from park, and down I'm writing limit 5. So limit 5 is probably a new statement that I'm giving here, which means that I don't want to select, of course, I wanted to select the name column from the park, but I just wanted to limit it to 5 entries. So that's the reason I'm giving limit 5, which means that the entire thing would work, but the only thing is it would limit the number of entries to 5. So like you can see, only 5 entries have been being displayed here from the name. So if you want to verify the output that you got with the path table, you can see that you're taking only the first 5 values, that is Cabrillo, Castle Mountains, etc. So all these 5 first entries are being displayed here. So that is about limit 5. So similarly, if I say limit 10, what would happen is it would basically query 10 names from the park table. Like the first 10 names have been displayed here. So that is what this command does. And going ahead, here you have select name from park where type is equal to national park. So now this is again a slightly complex way of retrieving data. So here in this statement, what you're doing is basically again you're taking this name column, you're basically working with the name column itself, and in the name column, basically you want to collect the names of elements in the name column where the type is equal to national underscore park. So you're taking only names from this column where the type here is equal to national park. So Channel Islands is one example. Then we can see the fourth entry, that is Death Valley, is an example. So basically, you're taking name from this table park where the type is national park. So that is what this command would do. And if I run that, like we discussed, Channel Islands and Death Valley. So these two were basically included. And as we scroll, we can see many others as well. So, for example, Joshua Tree is another example where the type is equal to national park, and Lesson Volcanic is also another example where the type was equal to national park. So this was about it. And suppose if you wanted to take where type is equal to monument, that also can be done. You just have to write monument here, and once you write monument here, all the names would be selected which have the type is equal to monument. So this is something that you can try by yourself by plugging in different other values that you know. So these are some of the names that have monument like Cabrillo, Castle Mountains, lava beds, and Tool Lake, and etc. So these are some of the basic commands that we learned today about SQL. Now, since this section has been completed, what you can do is you can just stop the app. So once the application is stopped, the virtual device is basically detached from this database. And now, if you rerun it, the connections are again established, and you can perform various other query commands on it. So this is about the SQL section of it. Now, what we are doing is we are basically introducing you to a new concept called rooms. So, what room is? Let us take a look. Learning to work with relational databases is a fundamental skill that you take throughout your programming journey. So, like we discussed, this aspect is a really important aspect when you consider the job interviews as well. When you consider job interviews, it is really important that you basically know how to work with relational databases and how you basically know how to query the exact results that you are expecting from relational databases. So that is really important for you to know. And knowing how relational databases work is also an essential for implementing data persistence in Android applications. So basically, at the end of the day, you want your Android application to work really fast. And data persistence, like we discussed about the definition of data persistence in the previous slides as well, where we discussed that data persistence nothing is nothing but keeping the data on your mobile device itself, so that next time you open the application, it is really simple for you to display all the data on your Android application. So that is something that you need to know about the relational databases and data persistence part. And moving to the third point, what is being said here is an easy way to use a database in an Android app is with a library called Room. So in our Android app also, when we saw when we took up the example of that first Android application we were building, we were basically importing room.column info, import androidx.room.entity and androidx.room.primary key. So this is what he's also mentioning here. So if at all you wanted to work with database, that's what we've been doing in this hands-on session until now. We have been working with a database and we have been querying results from the database, which we thought would add some kind of business value to our application. So an easy way to use the database in Android application app is with a library called Room. So Room is what is called as ORM, or Object Relational Mapping, which, as the name implies, maps the tables in a relational databases to the objects usable in Kotlin code. So we have basically even studied about object-oriented programming in Java, right? So these are some of the concepts like we discussed and we are discussing in every session that we need to basically remember and try to invoke those concepts into Kotlin. So similarly, we have something called as object relational mapping, and as the name suggests, it's just basically to relate the relational database that we have to the objects that we are creating in Kotlin and basically build some kind of relationship between them so as to gain some business value out of it. So now basically we are learning something about Work Manager, and let us see what Work Manager is all about. Work Manager is a recommended solution for persistent work. So what exactly this persistent work means is work is persistent when it remains scheduled through app restarts and system reboots. So there are some works that are really important to be carried out every time you open an Android app, right? So every time you open an Android app, basically the operating system has to boot. And what happens if the entire operating system is only not booting in your Android app? So if that doesn't happen, then you wouldn't be able to perform much tasks in it, right? So booting of the entire Android operating system on the Android device is a very important task to be performed. So without that, it would become really difficult to work with some other applications. So you can't work with basically any other application without the main operating system itself booting on your Android device. So that's what the second point says. And the third point says most background application processing is best accomplished through persistent work. And Work Manager is the primary recommended API for background processing. So we studied what exactly APIs mean. APIs basically stand for application programming interfaces. And in the further slides, we are basically discussing about what would be the advantages of using Work Manager. So here are some of the features of Work Manager that I would like to discuss here. So support both asynchronous one-off and periodic tasks. So asynchronous one-off tasks are tasks which basically are only repeated once, and periodic tasks are those tasks which are performed after a specific interval of time. So that's what the first point says. There are so many features of this Work Manager that you should know so that you can also try to implement them in your future application. And the second point says support for constraints such as network conditions, storage space, and charging status. So it also gives some support to such constraints as well. Chaining of complex work requests, including running work in parallel. So this is one very important concept. So when you study about processor and how a scheduler is basically scheduling different tasks, one important task is to basically run parallelly many tasks together. So a scheduler would basically, computer scheduler, what would it do? You can map this entire concept to what a computer scheduler would do. So it would basically map tasks or schedule tasks based on the priorities. If it is a high priority job, then sometimes what happens is the current executing low priority tasks would be basically paused, and the scheduler would basically deal with the higher priority tasks, and it would switch between tasks. So that is again called a concept called context switching, where many parallel processes are being processed at the same time, and that's what the third point says here. Output from one work request used as input for the next. So this is another important point. So in the previous slide, we basically talked about chained events, right? So chained events is when the output of one request is basically used as an input for the next input request. So basically a chain is forming if you can visualize it. So here are more features about Work Manager. So basically it has so many features that we can talk about. Uh, the next point says handling API level compatibility back to API level 14. So we had seen this also as well. And the note here is the last point. So the note here is Work Manager is the recommended solution for persistent work. So the same thing we have been, the same point we had seen in the previous slide as well. So that's the note here. And working with or without Google Play services, following system health best practices. Uh, so system health best practices, you have to basically follow some guidelines or some practices that are already mentioned so as to make sure that the system is passing health checks time to time, which means that we are just kind of confirming everything is on track or not. And then live data support to easily display work request state in UI. So what is live data? We basically saw that in the previous session. We discussed a lot about live data in deep by giving deep explanations. So the last point says work is persistent when it remains scheduled through app restarts and system reboots. So this was the same note that we studied some time back. So to make all this work in unison, a work manager is basically uh, used. So until now, we had been listening about and studying about what is persistent work. And in this slide, we'll be basically seeing what are the different types of persistent work that are available. So the different types of persistent work that are available include immediate, long running, and deferrable. So we'll see exactly what each of them mean as well. Immediate is tasks that must begin immediately and complete soon, may be expedited. So those are immediate kinds of tasks. So again, when we were mapping this to the computer scheduler, so we again saw there are different types of tasks that a computer scheduler would basically deal with, and immediate is one among them. So immediate says tasks that must begin immediately and complete soon. And long running are tasks which might run for longer, potentially longer than 10 minutes. So there are again these kinds of tasks. Basically, loading the operating system is also a kind of task. So um, that is about that. And the third is deferrable, which means that scheduled tasks that start at a later time and can be run periodically. So again, if you take the InShots application as an example, the news isn't constant throughout the whole day. So in order to explain the last point with an real world example, you can think of deferrable tasks as scheduled tasks that start at a later time and can run periodically. So if you start the application somewhere later during the day and you need to be basically getting some periodical updates about the news, you can consider that to be a deferrable task. So these are the different kinds of persistent works that are available, which is immediate, long running, and deferrable. So I think we can wrap up with the session.